suppose you and a friend are playing a game where 2 dice are rolled. If you roll a 5 or a 9 on the first roll, you win. If you roll a 4, 6, or 8 on the first roll, you lose. List the sample space for win and lose. So, you win by getting a 5 or a 9. If I roll 2 dice, how can I get a 5? I could have a 1 on the first and a 4 on the second, a 4 on the first, a 1 on the second. How can I get it with, we could do 2, 3, 3, and 2. Any other combination there? Okay.
Do we write in the middle? I was just going to show you I only have 2 places left.
I thought it meant issue sentence and then back to my shots. Stupid. I can't roll over to 9.
Don't worry, I'm erasing from like actually 5.
Yeah, I could.
Well, it was. No.
Why? We can make
I don't know.
and like we can take
Oh, yeah. Look at the.
didn't see that this
and it's not them.
Still gotta be cash. I think it looks good. I haven't even. That's pretty huge.
I got no, we can ready that one.
That would, I wouldn't mind. So.
It is Amigo.
So, your brother's gonna be so good at play. I just love it.
Edward is doing really good. Even though yesterday he was chasing somebody.
We took a selfie the other day. I love that.
They were chasing each other.
He literally came into my house. I just got my house monster. I said, food. And he, his belly goes, where's you're so fun.
Oh, yeah, he
took
was
a
back.
selfie the other day.
Behind the word.
Yeah, it's actually before you showed up. I actually have to walk in the bus.
I'll ask him tomorrow.
Alright. So that's the only way we can get a
Whoa.
5. How do we get 9s? 5 and 4.
4 and 5. 6 and 3. 3 and 6.
Okay, any others?
No.
Okay, so we lose if we get a 4. How do we get 4?
2, 2, 3, 1, 1, 3.
How do we get a 6?
2, 4, 4, 2, 3, 3, 5, 1, 1, 5.
Goodness gracious.
And how do you get an 8?
4, 4, 5, 3, 6, 2.
Okay, did I get them all?
I think so.
So,
Close enough.
the probability you win on the first roll. There are 1, 2, 3, 4, 5, 6, 8 options. And the total combinations, there's 6 options for the first and 6 for the second. So altogether, 36 different combinations. So that is your .2222.
I'm confused.
Okay, where did I lose you?
How do we get 6 and then 6?
Oh, so the total number of options. When I roll my dice, there's 6 options for the
Oh,
first,
okay.
6 for the second.
Holy the dice. Sorry.
Alright, the probability you lose on the first roll. So we still have 36 total options. 13 out of those 36 will cause us to lose. So that's .3611. Is that okay?
Stupendous.
Number 7. Alright. In a game of roulette, a player can place a $5 bet on number 17 and have a 1 in 38 chance of winning. If the ball lands on 17, the player wins $15. If not, the casino keeps the $5. What's the expected value to the player? So expected value is your mean. So we usually did these x p of x tables to get that. All right, so the player, if they lose, how much money do they lose? What's the probability that they lose?
30.
Yeah, you could do the decimal or you could say 37 out of 38, either way. Okay, they have a 1 in 38 chance of winning. If they win, they get $15, but it's really 10 because they paid $5 to play. The reason these numbers are what they are is because I want the value to the player. If it were the casino, it would be different, right? The casino would make $5 if they lose $10 if they won. So then we just multiply the x times p of x and add those together. And that's where I got -461. So on average, you would expect to lose $4.61 every time you play. So wouldn't work if you only played once or twice, but if you played 40 times, that's what you expect. You just really like losing your money.
I guess
But
I am the least addicted to playing card games out of everybody losing and winning.
It's one thing to play a card game, but especially
Get even or get even worse.
All right, on this one. This was the question, and I mentioned it yesterday. I meant to change these questions because I didn't really stress doing them by hand in class. We did one to show you where the formula came from. But I told you on the test you would probably not have to do these two columns, probably just the x and the p of x columns. So x are my different outcomes, my probability. We have to calculate that. So
100.
we add these all up, and you said how many?
1.
100. So 10 out of 100, so the probability of 0 is 0.1. It's there. Barely. Okay, so that's what you would expect to do on the test. Are we okay with that?
Yes.
These we did in class when we were learning the formulas and what they meant. X times p of x. So 0 times 0.1, 1 times 0.5, 2 times 0.05, 3 times 0.25, 4 times 0.1. And we did that on the previous question when we were doing our expected value too. X squared p of x, basically you already have x p of x, just take it times x again, so 0 times 0.
0.5.
You're doing, you have to take this to get x squared. You were trying to square the final answer.
Yeah.
You just have to take it times x again. So 2 times 0.1, 3 times 0.75, and 4 times 0.4. 1.6. Yeah.
How did you get the p of x again? What do you?
I took the frequency divided by the total. All right. So drawing a graph. Okay, you need all of them. So if you need to, you can even scoot 0 out to the side if you just need it to be easier to read. These are my x's, my probabilities. So then 0 had a probability of 0.1. I probably should not have counted by that much, should I? Should have counted by 0.1. 1 has a probability of 0.5. 2 is 0.05. 3 4 has a probability of 0.1. So that's our graph. If I asked you, could you describe the shape of that? I didn't here, but I have quite a few times on this, so I could have. The mean. So I would allow you to do this on your calculator. You just have to make sure this is your L1, your L2, and when you do your one variable statistics, this is your frequency list. Or the formula says you just add up the XP of X's. So either if you've done this column, you add it up, or you do it on your calculator and you get 1.7. Standard deviation, you would probably do on the calculator as well. Does everyone know how to do this on there? Okay, if not, you could use the formula. Either way, you should get 1.2196.
Do we do the one that has like the sigma?
Yes.
Instead of, okay.
The S1 will be left blank. It won't give you an S1.
So standard deviation will be on the calculator.
It'll just be the sigma. Variance, I haven't asked for that in a while, but if you look back at your formula sheet, that's just your standard deviation squared. So you should be able to get that. We haven't done that since the previous unit, but we could. It's finally getting nice outside today. It's cold all morning. All right. Is that one okay? Okay, problem 13. According to a survey, 20% of the victims say that it took 1 week to 1 month to recover from identity theft. A group of 14 identity theft victims are randomly selected in your hometown. What's the probability that none of them was able to recover from the theft in 1 week to 1 month? Okay, key thing to remember. We have a set number of trials. How many outcomes are there? 2. Either they recover in a week to a month, or they don't. And these people are all independent of one another. So this is binomial. Okay, so my n is 14, my p is 0.2. So I want the probability that none were able to recover. So that means my x is 0. So you go to your chart. Do we have this option? No. So that means we have to use our formula and do it by hand. So that's n, choose x, p to the x, 1 minus p to the n minus x. Does everyone know how I got that and how to plug it in? Yes. So if you put that in, you get 0.04. What's the probability that between 2 and 4 inclusive? That means x could be 2, 3, or 4. So we have to do all of these on our calculator. 14, choose 2, 0.2 squared. That means it would be 0.8 to the 12. For 3, 14, choose 3, so 0.2 to the third. That means 0.8 would be to the 11, or 14, choose 4, 0.2 to the 4th, 0.8 to the 10th. So we're putting all of those in. You can, if you want to do them individually, you should get numbers similar to this. So overall, it's 0.6723. So C wants the probability that at least 5. So if it's at least 5, that means it could be 5, 6, 7, all the way up to 14. Okay, that's a lot to calculate. But yeah, so we have a couple different options. We've already found the probability of 0, 2, 3, and 4. So we find the probability of 1 and subtract all of those off. Does that make sense? So if I just did the probability of one person, So that came out to be 15393. Oh, no, what just happened? So then you just do 1 minus the probability of 0 minus probability of 1 minus probability of 2, 3, and 4 that we already did. And that gave us 0.1298. So D is the probability that no more than 4. So no more than 4 means it could be 0, 1, 2, 3, and 4. So what do we have to do?
1 minus 0.129.
Okay. We could just do 1 minus the answer from above, or add up our 0, 1, 2, 3, and 4 that we've calculated. We'll get the same answer either way. We get 0.872.